Okay, let's go through this exercise together. Which statement about the masses and weight of an object on the earth is correct? A balance can only be used to compare weights and not masses. This is not true. A balance can be used to compare weight and masses. Heavy objects always have more mass than light ones. This is possible. Large objects always have more mass than small ones. This is not true. For example, I could have a very large piece of cotton compared to a very heavy steel ball. The large piece of cotton will not necessarily have more mass than the small one. A mass is a force, but weight is not. That's not correct as well. Mass is definitely in kgs, and weight is measured in newtons, so it should be forces as well. Question number 2, an object in a space probe above the Earth weighs 3.5 newtons. The gravitational field strength at the height of the space probe is 7.0 newtons per kg. This is the weight in space. This is the gravitational field in space. The gravitational field strength on Earth Earth's surface is 10 newtons per kg. This is the gravitational field strength of Earth. What are the mass and weight of the object on Earth's surface? Now, first and foremost, in order to find the mass, we should remember that W is equals to mg. From here, mass would have been W over g. In this case here, it will be 3.5 divided by 7. Why do we not use this 10 here instead? Is because the weight here is the one in space, and this is the gravitational field from space here. So from here, I know that the mass is going to be 0.5 kg. Once I have the mass of 0.5 kg, I can find the weight on Earth, which is yet again W equals to mg. In this case here, it will be 0.5 times 10, which will be 5 newtons here, and answer should be boy. A piece of steel is taken from Earth to the moon for an experiment. The gravitational field strength on the moon is smaller than Earth. Okay, the gravitational field strength on the moon is smaller than the gravitational field strength on Earth. Which statement about a piece of metal is correct? It has less mass on moon than Earth. This is not true. Mass will not change regardless of wherever you go. The mass should be the same. It has more mass on moon than Earth. This is not true as well. It weighs less on the moon than Earth. This is possible. It weighs more on the moon than Earth. This is not possible, simply because the weight is less on the moon is simply because the gravitational field strength is less than that of Earth. A measuring cylinder containing only water is placed on an electronic balance. A small irregular shape of stone is now completely immersed in the water. The diagram shows the equipment before and after the stone is immersed. So before it was 40, after it was immersed it was 50 here. Before the stone, the mass of the water and the measuring cylinder was 105. With the stone, it is 217 grams, 217.5 grams. So from here, in order to find the mass of the stone, it is basically 215 minus 105. In this case here, it will be 112.5. What is the density of the material of the stone? Density's formula is mass over volume. In this case here, it will be this will be 65 instead, guys. It should be 65. It will be 112.5 divided by 65, and you should be able to get a final answer of 1.73 if you did the calculation properly. Okay. In which pair are both quantities measured in newtons? Obviously, force is measured in newtons, pressure is in pascals. Force and weight are both in newtons. This will be in kg, this will be in pascals, kg and newtons. The mass of a measuring cylinder before and after pouring some liquid into it are shown in the diagram. Initially, the mass of this cylinder is 80. The mass of the cylinder with water is 180. So from here, I know for a fact that the mass of the liquid would have been 100 grams. What's the density of the liquid? In order to find the density of the liquid, I need to find how much is the volume. Here will be 100, 120, 140, 160, 180, and 200. So 100, 120, 140, 140 cm cube. So from here, density is yet again mass over volume. In this case here, it will be 100 divided by 140. So from here, it will be boy as your final answer. Always check your units and see if it is the same. If it's the same, then you're okay. What are the units for mass, pressure, and velocity? Mass should be in kg, pressure should be in pascals, and velocity should be in meters per second. Answer is no other than boy. A steel ball bearing has a mass of 24 grams and a density of 8 grams per cm cube. It is lowered into a measuring cylinder containing 12 cm cube of water. What is the new level of the cylinder here? Now, first and foremost, we have to find the density of the ball, which is density equals to mass over volume. Again, sorry, we have to find the volume of the ball. So volume would have been mass over density. In this case here, it would have been 24 divided by 8, which will give us 3 cm cube. Now, if the water started off at 12 cm cube, what will the new water be? It will be basically 3 plus 12 lah, which is essentially 15 cm cube here. Right? Moving on to the next part. Figure 2.1 shows a vehicle designed to be used on the moon. The brakes on the vehicle are tested on the Earth. The acceleration of free fall on the moon is 1/6 of the value of Earth. When they say the acceleration of free fall, this is supposed to be the gravitational acceleration on the moon, which in other words is the gravitational field strength. Take one box in each column of the table to predict the value of the quantity when the vehicle is used on the moon, compared to the test on the moon. First and foremost, they want us to find the mass of the vehicle on the moon. Now, yet again, mass does not change regardless of wherever you go, so it should have the same value on Earth. The weight of the vehicle is definitely affected by gravity, so in this case here, it will be 1/6 the value of Earth, since the gravity is only 1/6 the value of the Earth. And the acceleration of the vehicle with the same braking force should be the same. Why? Because if this thing here is decelerating, it is actually applying a horizontal force. Gravitational field strength is a vertical force. Vertical forces will have 0 effects on the horizontal forces and thus should be the same as the value of the Earth. Okay, moving on to the next part here. The gravitational field strength of the moon is 1.6. Astronaut has a mass of this. What is the weight of a moon? Blah, blah, very easy. Weight equals to mass times gravity. It will be 1.6 times 75. 1.6 times 75 will give you exactly 120 newtons here. A measuring cylinder containing 30 cm cube of a liquid. Some more of the liquid is added until the liquid level reaches the 50 cm mark. It goes up from 30 to 50. The reading on the balance increases by 30 grams. So the volume increased by a total of 20 cm cube. The mass increased by a total of 30 grams. What's the density of the liquid? Easy, density is equals to mass over volume, which in this case here will be 30 divided by 20, which is obviously going to be 1.5 in this scenario here. An object always has mass but does not always have weight. What must be present and acting on the mass for it to have weight? Obviously, it's supposed to be a gravitational field, right? The gravitational field is the thing that pulls the mass downwards. Which statement about the mass and the weight of the object is correct? They are both affected by change in acceleration. This is not true. Only weight is affected by acceleration. They are both forces. This is not true. Mass is in kg. They have different units, definitely. One is in kg and one is in newtons. Weight is calculated by dividing mass by the acceleration. You know what this means? It says that weight is calculated with mass divided by gravity. This is definitely not true because the formula is W equals to mg, right? So answer is C. Which statement about the mass of an object is correct? It is equals to the density divided by the volume. That is not true as well. Density's formula is mass over volume. In order to find mass, it is density multiplied by volume. It's not true. It is equals to the weight multiplied by the gravitational field strength. This is not true as well. Mass is supposed to be, weight, W equals to mg. So W over g is equals to mass. It is affected by the gravitational field strength. This is not true. Mass does not change regardless of wherever you go. It is a property that resists change in the velocity. This is definitely true because velocity is going to cause momentum of a mass which will be pushing it forward, right? So answer is definitely donkey here. A person steps onto a bathroom scale. The bathroom scale records both mass and weight. Which row shows the reading of the scale? 16 newtons, 600 kg. The units are not even correct. Anything with the wrong units is automatically wrong. 600 kg, 60 kg equals to 600 newtons. That is definitely true because gravitational field is somewhere around 10 meters per second square, right? So W equals to mg. From here, if it's 60, you multiply it by 10, you will get 600 here. An object has a weight of 7,600 newtons. This is the weight. In a gravitational field strength, this is the gravity. What is the mass? W equals to mg. Once again, m will be equals to W over g. In this case here, it will be 7,600 divided by 100. You will get 76 kg here. A rectangular container has a base of dimension blah blah blah. This is going to be the area. The container is filled with liquid. The mass of the the mass of the liquid in the container is 4.8 kg. What is the weight of the container? W equals to mg yet again. In this case here, W will be 4.8 multiplied by 9.8. Press that into your calculator. 4.8 multiplied by 9.8, you'll get a total of 47 newtons here, correct to two significant figures. Figure 2.1 shows a hollow metal cylinder containing air floating in the sea. The density of the metal is greater than the density of seawater. Explain why the cylinder floats. Now this here is actually a conceptual question. They're trying to trick you guys. They're trying to make you think that with a greater density, by right is supposed to sink to the bottom, right? But in this case here, they're asking why does the cylinder float even though the density of the cylinder is greater. Now the keyword here is because the cylinder also contains air, guys. If the cylinder contains air, and we know for a fact that the density of air is much less than water, the average density of the air combined with the cylinder is still less than the density of the seawater, and that is why it floats on top, guys. You should write something like average density of the cylinder with air is less than the density of seawater, and thus it is able to float lah. Right, so this is supposed to be your answer here, guys. Alright, you're supposed to mention the average density. Then moving on to the final exercise here. The mass of a full bottle of cooking oil is 1.3 kg. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.9 kg. So from here, we can say that, you know, obviously the difference here to here is going to be 0.4 kg, right? What is the mass of the cylinder? If 0.4 kg was half the liquid, right, it was half this liquid here, this other half will be 0.4 as well, right? So if I want to find the empty bottle, it should be 0.9 minus 0.4, which is going to give you a final answer of 0.5 kg here. right? This is 0.4, this is 0.4, 0.4, 0.4, and yeah, 0.5, that's correct. A solid ball has a volume of 4 cm cubed. The density of the ball is blah blah blah. What is the mass? Density equals to mass over volume. Always write down your formulas here, right? Mass would be density multiplied by volume. In this case here, it will be 1.6 multiplied by 4, which will obviously be 6.4 grams. A body is moved from place X to place Y where the gravitational field strength is different. What happens to its mass and the weight due to this move here? The mass is never ever going to change, right? The weight is definitely going to change because it has a different gravitational field strength. From here, the diagram shows 4 solid blocks with their dimensions and masses. Which block has the greatest density? They give you the area and height. You're supposed to find the volume. Volume here would have been 20. The volume here would have been 20. The volume here would have been 40. The volume here would have been 40 as well. Density will be mass over volume. So it's 14 divided by 20. It will get 0.7 here. 54 divided by 20. You're going to get 2.7 here. 48 divided by 40 will be 1.2. 68 divided by 40 will give you a total of 1.7. Answer should be C here because it has the greatest density. 4 students make statements about the mass of an object. Which statement is correct? The mass of an object depends on the gravitational field. Wrong. The mass of an object divided by its weight is equals to the acceleration of the free form. Weight equals to mass and gravity. Weight divided by mass is supposed to gravity. This one says mass divided by weight. This is not true as well. The mass of an object increases when this is definitely not true. The mass of an object resists change in the motion. Yeah, definitely true. A metal has a density of 8 grams per cm cube. A solid cube has a mass of 1 kg. It is made from the same material, same metal. How long is each side of the cube here? Ooh, solid cube. This one here is going to be this, right? It's just cube root 8, right? Because it's a cube, right, with the same dimensions of the width, the length, and the height, right? An object on Earth, a spring stretches by 5 cm when its mass is 3 kg, is suspended from one end. The gravitational field strength of the moon is 1/6 of the Earth. Which mass on the moon would stretch the spring by the same extension? Oh, interesting. On Earth, a string stretched by 5 cm when it has a mass of blah blah blah. So assuming that was 30 newtons here. 30 newtons, this one here would have been the spring constant. F is equals to kx. The k in this case here will be F over x. It will be 30 divided by 5, which is going to be 6 newtons per cm. Now, right now, the gravitational field on the moon is 1/6 of the Earth. So 1/6 of the Earth will mean to say I need to times 6 here, right, for it to stretch the exact same length. So in order for that to happen, the answer can be no other than donkey, right? Now this question here, guys, you have to see what they want from you. First and foremost, they say that 3 kg, which is 30 newtons on Earth, stretches it by 5 cm. If the gravitational field strength of the moon is 1/6 of the Earth, it means to say for the exact same mass, I only have 1/6 of it, which is going to be 5 newtons here. 3 kg is only going to be 5 newtons on the moon. Right, in order to get back 30 newtons, I must multiply it by 6, and thus I should multiply this by 6 here, which will give me an answer of 18 kg here. Right, this here is not really needed. X, Y, and Z are 3 regular shaped objects. Their dimensions and masses are shown. 5 times 10 times 2 is going to be 100. 624 times 3 is 72. 125, this is 25. Which object has the same density? Density equals to mass over volume. 200 divided by 100, this will be 2. 200 divided by 72 is not going to be the same. 50 divided by 25 is going to be 2. So object X and Z should have the same density. Right. And finally, figure 2.1 shows a sign that extends over the road. The mass of the sign is blah blah blah. We want to find the weight of the sign. W is equals to mg. This is obviously a m, right? So it's going to be 3.4 times 10 to the power of 3 multiplied by 9.8. Press that into the calculator. 3.4 times 10 to the power of 3 multiplied by 9.8. You will get a rough number of 33320, which is going to be changed to standard form of 3.33 times 10 to the power of 4 newtons instead. This should be written at this dotted line here. Okay. Okay, final question, final exercise, Diagram 1 shows a piece of flexible metal that contains many pockets of air. Diagram 2 shows the same piece of flexible material after it has been compressed so that the volume decreases. What happens to the mass and the weight of the flexible material when compressed? It should both not change at all. Compressing an object is not going to make it any lighter, guys. It will make it smaller, but it's not going to make it any lighter. The graph shows how the strength of the gravitational field strength varies as the distance from the Earth's surface. Basically, they're saying that the further you are away from the surface of the ground, the less the gravitational field strength is acting on the object, thus making you weigh less, which will describe the effects that this has on the mass on the weight of an object as it moves further away from the Earth's surface. Mass is definitely not going to change. The weight is definitely going to decrease simply because the gravitational field strength decreases. The measuring cylinder contains 40 cm cube. This is definitely volume. The metal ball is dropped into the water and the water rises to 56 cm cube. So this is going to be the volume of the ball would have been 16 cm cube, right? The metal has a mass, the mass of the ball is 80 grams. What is the density of the metal from the ball is made? Density is equals to mass over volume. It will be 80 divided by 16. Press that into your calculator. You should get exactly 5 grams per cm cube. A mass of 6 kg rests on the surface of the planet. On this planet, the gravitational field strength is blah blah blah. What is the weight? W equals to mg. 6 times 20, very straightforward, it would be 120 newtons. The mass of a measuring cylinder is 190 grams. 400 cm cube of the liquid is put into the measuring cylinder. The total mass of the measuring cylinder and the liquid is blah blah blah. So I want to know the volume, the mass of the liquid would have been 560 minus 190, right? Which in this case here will be 370 grams. This is the mass of the water. 4 solid objects are lowered in turn into the liquid. The densities are shown. Blah 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 blah. So in order to know which one is going to float, they must have a lower density, right? First and foremost, I need to find the density of the liquid. Density is mass over volume. In this case here, for the liquid would be 370 divided by 400. Press that into the calculator. You'll get 0.925 grams per cm cube. Anything that is less dense than 0.925 will float, meaning to say the answer can no other be A and B, 1 and 2 here. The space probe is taken from Earth to Mars. The force of the of gravity on the surface of Mars is less than the force of gravity on the surface of the Earth. Basically, they're saying that gravity of Mars is less than the gravity of Earth. How do the weights and mass of the space probe compare to the values, blah, blah, blah. Mass is definitely going to unchanged. So answer is definitely going to be between B and C. Weight on the Mars is definitely going to decrease because it has less gravitational field strength. So B is definitely the answer here. Water has a density of blah 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 blah. The rectangular swimming pool has an average depth of blah blah blah. The length is this blah blah blah. We need to find the volume first, which is 1.6 multiplied by 25 multiplied by 10. You'll get a 400 meter cube volume here. What is the mass? Density is equals to mass over volume. Mass will be density times volume. 400 multiplied by 1000. It will get exactly 400 kgs here, 400,000 kgs here. Which row gives the correct weight for the mass shown? The value of G is blah blah blah. First one is the correct one already, times 10, right? The rectangular gymnasium has 50 meters long, blah 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 blah. You find the volume first, which is 50 multiplied by 25 multiplied by 8. Volume would have been 10,000 meters cubed here, right? The density is blah blah blah. What's the best estimate of the mass of the air in the gymnasium? There's no need for estimation. Density is equal to mass over volume. Mass would be density multiplied by volume. 10,000 multiplied by 1.2, you will get exactly 12,000 kg here, right? Very easy and straightforward. And final question for this exercise here. The scientist fills a container with seawater. The container has a dimension of blah blah blah. The density is blah blah blah. Now I do want to highlight one thing, guys. You should notice when you're doing the calculation that this is all in cm and this is in meters cube. Meaning to say you either change this all into meters or you change this into cm cube. Of course, I would choose to change it all into meters, which will be 0.3 multiplied by 0.3 multiplied by 0.4. Press that into the calculator, 0.3 multiplied by 0.3 multiplied by 0.4. The volume here would have been 0.036 meters cube. From here, if I want to find the mass, density is yet again mass over volume. Mass would be density multiplied by volume. In this case, it will be 1020 multiplied by 0.036. Press that into the calculator. You'll get a final answer of 36.72 kg. But you cannot write more than 3 significant figures in this dotted line here. So you should have 36.7 kg written here. Alright, and that is the end of the mass weight density exercises.